Have you ever wondered where this term QNH comes from and how it's useful to pilots? Well, you don't have to be confused anymore because in this video, I'm going to explain everything you need to know about QNH. Now, QNH is related to altitude, and the way we measure altitude is through air pressure. Air pressure reliably tells us how high we are, and that's because every 1,000 feet we climb, the air pressure goes down by 30 hectopascals. So we know that if the air pressure has gone down by 60 hectopascals, then we've gained about 2,000 feet. Yes, it's not exact, but it is good enough for aviation. Now that we know what altitude changes by as we get higher, we still need to know what the reference should be. Because if the reference is different for everyone, and everyone's going to be at different altitudes, we need to know exactly what the reference of zero is going to be. And if the zero altitude is the same for everyone, then everyone in the sky is going to read the same altitude relative to each other. So it's very important that we all agree what zero is. And in aviation, at low altitudes, in general aviation, we want to know how high we are above the sea. We don't care about the terrain that much because terrain changes, it's very bumpy and it's not reliable to know how high we are. Instead, the sea is fairly flat. We know that pressure changes at a reasonably uniform rate as we go higher, and our reference is going to be sea level, which is the lowest point an airplane can really go. Go underwater, you've crashed. So, how do we know then what the pressure at sea level is? Well, there are specific instruments at sea level which always record the pressure at sea level. And when we are in the airplane over here, these instruments will send us through radio waves, will send us the air pressure at sea level. So if every single plane in the sky sets this pressure to be zero, then everyone will be reading the same altitude and there won't be any mismatch where one person thinks they're at 3,000 and the other person thinks they're at 5,000, but really they're at the same altitude and they're on a head-on collision. The problem is this pressure at sea level is not constant. It would be really good if it was constant because then everyone could just memorize one pressure, set it on the altimeter to read zero, and we would be off and away. But unfortunately, it changes and it changes quite a bit throughout the day. That's why we got these instruments at sea level which always tell us what the pressure is so we can keep updating our altimeter. So then, this pressure at sea level, whether it's 1013 hectopascals, whether it's 1025, whether it's 996, whatever it is, this is, ladies and gentlemen, the QNH. And this actually stands for query nil height. So query, what is the pressure nil height, at 0 feet. So sea level is considered to be 0 feet, nil height, and we just want to know what the pressure is at 0 height. Now you might be thinking, well, Rachel, I'm at an airport and I set the QNH, but my altimeter's not reading zero. You said QNH is the zero pressure, right? Well, here's the thing. If you are at sea level and you set the QNH, let's say the pressure here is 1014 hectopascals at sea level, at this level. If your airplane is at the sea level as well, then it will read zero on the altimeter. So the altimeter here would read zero. Now, obviously you don't want to be at sea level unless you're a seaplane. Seaplanes are cool. But only unless you're at sea level, if you set QNH, your altimeter will not read zero. It's only if you're at sea level, it will read zero. Now, your airport could be up here. And your airport could be 1,000 feet above sea level. And you set QNH on your altimeter. So on the side here, you set 1014. So it's 1014. Your altimeter is not going to read 0 everywhere. It doesn't work like that. You set QNH, and now your altimeter is going to say, all right, you set 1014, that means the sea level pressure is 1014, and you are only going to be at 0 feet if the pressure outside is 1014. Remember, the pressure outside is 1014. Altimeter thinks, all right, you set 1014, that means I'm at sea level, because sea level is always 0 when you set QNH. Here, the outside pressure is actually 984 hectopascals. If you took a reading of the air pressure here, it would say 984. That means the altimeter has seen that sea level is 1014 and outside is 984. There's a 30 hectopascal difference. That means we're 1,000 feet above sea level. So it's going to read 1,000. And guess what? That is your elevation. So when you set QNH on your altimeter, the process of steps is altimeter thinks that pressure you set, aka QNH, is pressure at sea level. Then next is that pressure equals 0 feet. So whenever it senses that same pressure outside, it will read 0 feet. Then it takes a pressure difference. So if you're actually at 984 hectopascals outside, then it will take the pressure difference, which is 30 hectopascals. So delta P equals 30. Then finally, it will take the difference and it will convert it into an altitude. And that altitude is just your height above sea level. It's the difference in pressure between sea level pressure and outside pressure. And what you see is a difference in altitude from 0 to however high you are above the sea. Hope that helps. Hope you learned something there, and stay safe in the skies.